Hello everyone, we've got a quadratic modelling question here. So question 9, it says the graph in figure 3 shows the path of a small ball. The ball travels in a vertical plane above horizontal ground. The ball is thrown from a point A, represented by A, and caught at the point represented by B. The height in meters of the ball above the ground has been plotted against the horizontal distance x meters, measured from the point where the ball was thrown. With respect to a fixed origin O, the point A has coordinates 0, 2, and the point B has coordinates 20, 0.8, as shown in figure 3. The ball reaches a maximum height when x is equal to 9. A quadratic function linking h and x is used to model the path of the ball. Find h in terms of x 4 marks. Okay, so there's various ways we can do this, but I've just chosen to start off by writing down the general form of a quadratic. So the height is equal to ax squared plus bx plus c. Now I've chosen to, for my next step, to rewrite this now as minus ax squared plus bx plus c, because I can see that what I've got here is a negative quadratic, okay? You don't need to do that, but I've just chosen to do that. If you left it like that, you would just find out that your a turns out to be negative. Okay, but I've written it like that. So now we're going to start putting in all the information that we know in order to try and deduce the equation. And I think the first thing that sort of like stands out to me is the fact that here, when the ball is thrown, when x is 0, h is 2. So we can use that first piece of information, that when h is 0, x is equal to 2. So when h is 2, x is 0, sorry. So I put h as 2, x is 0, and I get that c is 2. So now we've made an improvement. We've got that much of our equation now. What's the next step? When the ball is caught over, when x is 20, it's caught when h is 0.8, so over here, there. So we can sub that in as well, and that's going to help us a little bit more. So it's caught at a height of 0.8 when x is 20, and that gives us this equation here that has in it a and b. So we've got one equation with two unknowns. Okay, so what else are we told? We're told that the ball reaches its maximum height when x is 9. So that means we can say that dh by dx, the turning point, occurs when x is equal to 9. So we can differentiate our expression, and if you remember, my version was that h is equal to minus ax squared plus bx plus 2. So I differentiate that, I get minus 2ax plus b. I'm going to sub in x equals 9 in there, and I get this second equation, okay, with two unknowns again. So we now have two equations with two unknowns, equation 2 and equation 1. And I'm now going to sub equation 2 into equation 1. So let's do that. So this is now putting equation 2 into equation 1, subbing it in. We find out we get the following, okay? We get minus 1.2 is equal to minus 400a plus 20 times 18a from subbing in that one equation into the other. So we just expand the brackets, collect like terms, and we find out that a is 0.03. Once we know that a is 0.03, we go back to our b, any of the other equations, to work out b. And b turns out to be 0.54. So we now have our full model there for the modelling the motion, the quadratic there, modelling the motion of our ball. And that's part A done. Part B, give a limitation of the model for 1 mark. The mark scheme was exceptionally generous. They're not always this generous, but they seem to allow pretty much anything. So they said that they would accept that the model does not take into account the fact that there could be spin on the ball. The model does not take into account the fact that there is air resistance. The model does not take into account wind. The model does not take into account the physical dimensions of the ball. They even put that the model doesn't take into account that there could be trees, of all things. I can't believe that they accept trees, but they seem to be accepting pretty much any sensible solution there, any sensible suggestion there for that one. Now part C, it says Chandra can catch the ball if it is less than 2.5 meters above the ground. Use the model to determine whether or not Chandra can catch it. Oh, I've said Chandra is standing directly under the path of the ball at a point 16 meters horizontally from O. Can Chandra catch the ball? So basically, here's our model. So there it is going like that. There's Chandra. And we want to know, can Chandra reach up and catch the ball or not? So Chandra is stood here where x is equal to 16. So all we need to do is work out what is h when x is 16. And we work that out and we find out that we get that when x is 16, h is equal to 2.96. Now the question tells us that Chandra can only reach up to 2.5 meters. So Chandra cannot catch the ball because the ball is at 2.96 meters. Perfect. I hope you found that helpful, and I'll see you in the next video.